Hello there, I'm Thomas Hatsios, German-American pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport. We're gonna be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport, runway 14 for an ILS localizer landing. So now I'm in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and Microsoft Flight Simulator X. I'm gonna start showing you the cockpit instruments, the displays, and the functions of the Boeing 787 900Z aircraft. I'm going to start with the primary flight display that displays the airspeed indicator, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in tens, hundreds, and thousands of feet per minute, all the steepness of the trigonometric angles in degrees he can climb and descend, also the altitude indicator with the artificial horizon, the pitch ladder in degrees and the bank angle in degrees, the ILS localizer, the horizontal localizer, and the vertical glide slope that receives from the onboard antennas of the aircraft that receive the radio frequency transmitted from the threshold runways antennas that transmit the radio frequency that will help us to align the aircraft with the magnetic north pole heading of 136 degrees of the runway 14 we're gonna use in Zurich International Airport, Lszh in Switzerland, both for takeoff and for landing. So we're gonna be aligned with the horizontal localizer, vertical glide slope, the ILS system, the instrument landing system. You can see also the ILS localizer cross in the primary flight display. You can see also the flight director cross for manual guidance of the aircraft and the autopilot cross for automatic guidance of the aircraft. We have also the XSI, the horizontal situation indicator, that displays the magnetic heading and track, and also the integrated display of the aircraft flight plan. We're gonna create a flight plan or a flight path or a route using the flight management computer. Later I'm gonna show you how create a flight plan. I'm gonna input all the data of the aircraft. You're gonna see also the flight plan displayed in the navigation display, both in horizontal and vertical navigation modes. You can see the profile of the aircraft and the flight plan. We follow both in the LNAV and the VNAV, the lateral navigation and the vertical navigation. You're gonna see later in the panels here of the displays how I'm gonna use the autopilot flight director system panel, the flight management computer, to fly the aircraft if we need in autopilot and flight director system and auto throttle modes. So we can also fly manually. We have the navigation display that displays the geographic, the magnetic north pole and geographic north pole and magnetic variation depending on where we are in the world. We have the terrain map with the weather and radar reflections. From the weather radar, the terrain reflection, you can see the terrain displayed with red, green, and yellow, depending on the elevation around you, and also the distance. You can see again horizontal and vertical profile. You can see the terrain map with the red, the yellow, and green, and also the blue for the sea, the lakes, and the rivers. You can see also the airports displayed with a 4-letter name. So we have our own airport. The taxiways and the runways we're gonna use for takeoff and for landing are displayed from the GPS. So also we have the other airports. We can see like right now we have 80 nautical miles of range over here of distance displayed. We can look even further or closer. So we're gonna see also we have the navigation aids, the nav aids displayed. In the navigation display we have the workstations, ADFs, and DBs, also the waypoints which are horizontal and vertical navigation fixes the aircraft. We're gonna have to fly through some waypoints. We're gonna select from the flight management computer, and they're gonna be displayed again as we're gonna create a flight plan. It's gonna show us a purple or magenta line and connect the stars and waypoints in between. So we're gonna have this also displayed in the navigation display. We can see also other aircraft that fly around our own aircraft displayed using the transponder, the ADSB and ADC transmitter receiver that transmits our frequency to other aircraft in the air traffic control and receives from other aircraft. It can display the other aircraft and makes calculations about the radio frequency receiver and its computer can calculate the other aircraft distance from our aircraft as we fly over on the ground, altitude difference between our aircraft and the other aircraft, how many hundreds or thousands of feet are above or below us, also whether they climb or descend with respect to our aircraft, and also can calculate the velocity closing in, the velocity between our aircraft and the other aircraft. It will show us the diamond shape of the aircraft. It will give us the TICA system, traffic collision advisory system. It will give us a warning advisory if we have an incoming collision with another aircraft. You can see also that we have the autopilot flight director system panel, the thrust levers, the engines indications, the flight management computer. I will show you also, so stay with me until the end part of the video. You're gonna see the complete flight full manual. After I will complete all the explanation of every system of the aircraft and make the engine start demonstration and set up the flight management computer, you will see the complete flight from takeoff, climb, cruise, descent, approach and landing after like 25-30 minutes. So stay with me. I'm gonna show you a couple more things here. So you can see here also the outside view over here. You can see the flight controls. I'm using this side stick to control the flight control. So we have the elevator for climb and descent. This is the similar like the Airbus side stick. So we use it to control the Boeing aircraft. You can see we can use the control wheel to make left and right turns, ailerons and spoilers, and also the elevator for climb descent, which is the pitch axis of the aircraft, the roll axis, make left and right turns, and also the rudder pedals, which is the yawing axis of the aircraft. So you can see also we have the thrust levers here connected, so I can actuate the thrust produced from the engines as I command the FADEX. The FADEX are the full authority digital electronic control computers, one installed per engine gearbox, dual channel redundancy. If one channel fails, the other takes over. Controls modes also displays all the engine data. You see in the upper and the lower ACAS engine indication and cruise system display like the N1, which is the low speed starter shaft, the low pressure compressor and turbine of the turbofan, which is engine, the exhaust gas temperature per engine, the N2, which is the high speed starter shaft, the high pressure compressor and turbine of the turbofan, which is the engine, the fuel flow per engine per hour in 1000 kilograms or thousands of pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. The FADEX also control, monitor, and do other things like control the outflow valves of the 5th and 9th stage that supply over here the cabin pressurization. As you can see, I'm gonna show you cabin pressurization, hydraulic fluid tanks pressurization. They pressurize the engine pressure, supplies pressure for the hydraulic fluid tanks, so we can move the flight controls around, as you can see, or the landing gear or the parking brakes or the nozzle steering and other things, the thrust reversers. Also we have cabin pressurization, air conditioning, ventilation, oxygen regulation in flight, and also over here we have so this the main components: wing and engine at the eyes, the hydraulics and the pressurization, air conditioning over here, the electrical panel over here. So I'm gonna show you how to use every system, the primary flight control computers over here, the engine auto start over here, as you can see, the fuel on board the aircraft, the fuel tanks, fuel booster pumps. So also they do other things I will explain later. So you can see here the engine indication. You can see the N1, which is low speed starters, have low pressure compressor and turbine of the turbofan with the engine, exhaust gas temperature engine, N2, which is the high speed starter shaft, high pressure compressor and turbine of the turbofan engine, the fuel flow per engine per hour, 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity and vibration of the N2 stage of the engine. Also you can see the outflow valves here, the cabin pressurization as we climb and we descend, the rate of climb, descend, the differential pressure inside and outside, so we can go 8 psi as we climb or we descend, the cabin altitude, is gonna be 8,000 feet and maximum flight altitude like 45,000 feet. So this give us some, and the outflow valve we can monitor here. So we will see all the systems. You can see also we have the horizontal stabilizer trim, rudder trim, the flaps position. The landing gear is down right now. Also the gross weight for takeoff and the fuel on board. I'm gonna see them also from the flight management computer here later. We can control all the things. So we have the primary flight display over here. You can see the airspeed indicated, the airspeed tape over here. The airspeed selected from the autopilot flight director system panel. The altitude tape, the barometric altitude right now is 1,430 feet. The rate of climb descent of the aircraft in tens, hundreds, and thousands feet per minute. The seatbelts of the trigonometric angles increase can climb descent. You can set from the autopilot flight director system panel. We have the same values for the airspeed selected, commanded over here 200 knots, heading 360 degrees. We cannot change later. And altitude selected at 10,000 feet, vertical speed here. Also we have autopilot engaged, disengaged, auto throttle left and right, airspeed guidance, flight director here, LNAV and VNAV, lateral navigation, vertical navigation, flight level change over here, auto throttle climb continues. So you can see same values here displayed in the primary flight display that display all the air data from the pitot static and pitot dynamic for the dynamic airspeed and the barometric altitude. So we have also the air data computer over here. You can see IRS alignment and heading reference. So this is the air data computer. We have the primary flight control computers also and flight control services. So the air data computer contains the controllers for the pitot static, pitot dynamic, the airspeed, the altitude, the GPS position, the inertial alignment, the magnetic north pole, geographic north pole. Over here, the coordinates of the aircraft, GPS coordinates. Also the laser gyroscopes for the laser alignment of the aircraft and gyroscopic precession and acceleration as we fly, and the altitude and other stuff. So these are displayed here. The angle of attack of the aircraft as we fly. You can see the radio altitude above the ground level is 2 feet. So we have also the pitch altitude here. You can see 2.5, 5, 7.5, 10, 12.5, 15, 7.5, 20 degrees for pitch up or pitch down. Also the bank roll of the aircraft as we fly, how many degrees we can bank roll. The flight mode and zero, the autopilot and the auto throttle. Later on vertical navigation mode. So when we go for takeoff, you're gonna see this needle is gonna move up as we climb or move down as we descend. Also we have set the barometric altitude here. You can see 29.92 inches of mercury, and the radio minimums landing altitude need to be set. So we have 29.92 inches of mercury, which the star barometric give us this barometric altitude we set over here from the FS panel. As you can see, we have this switch here. You can turn around. It will set us inches of mercury, hectopascals, minimums, radio baro. The plan menu over here, we can change the displays here. The range of the display. So this is very important for the barometric altitude, inches of mercury, 29.92 or hectopascals, 1013 hectopascals. This give us this 29.92 inches of mercury, and this barometric altitude for flying. So we're gonna look over all these things, the systems. So a couple more things to see. We have some other things, the systems here, CDU, gonna look later, info, checklist, communication, navigation display, the engine. This switch is for the engines display, just so. Weather radar, traffic on the display and terrain, accept, cancel, reject, some warnings over here. So you can see the horizontal and vertical profile of the navigation display. Also the altitude we have selected 10,000 feet here. The display is 10,000 feet, and here 10,000 feet. You can see this line when we're gonna climb, fly over 10,000 feet. Also, as we are aligned with this line, you can see the aircraft symbol over here. So we have the heading here, the VOR ABFs over here. So I'm gonna show you a couple more things. So we need also to look at these things, the flight controls, as I'm telling you. So the FAREX, you see the engines controls here. Also control other things. I will explain in a couple of minutes. I have to show you first the flight controls. I'm descend. Also show you the outside view of the aircraft. I will show you the outside view, and now I will explain you the Newton's physics, aeronautical and aerospace engineering, and some principles we need to know for flying the aircraft, for the air transport pilot license, and for the commercial pilot license. So we need to know the aerodynamics and the forces of flight. So I will show you the aircraft from the outside view, and I'll talk to you about the aerodynamics of the aircraft. And so you can see here we have the wings of the aircraft. The forward wings hold mainly the aircraft weight as we fly over the surface area of the wings. So we can see also we have the thrust vectors from the engines, the jet blast. So this is a jet aircraft. You can see the jet engines, turbofans with jet engines, GNX. So you can see the jet blast here, the cone. That exhausts the propulsion. You can see we have the front fans, the compressor, the turbines, the left and the right wing engine. So we have also here the mean aerodynamic chord position of the forward wings, when the maximum aerodynamic lift occurs in the forward wings when we fly. Also where the stall begins as we fly, the airflow becomes detached from the top surface of the wings all the way back. So we need to avoid the stall. We need to monitor here the airspeed tape over here, the airspeed indicated, the primary flight display will show us the airspeed, and below the airspeed we need to have the stall speed with yellow and red indication. We need to have a higher airspeed, the thrust when flying, or maintain a pitch altitude down to avoid the stall. So you can see also we have the center of pressure in the top surface where the mean aerodynamic chord is. It moves forward and aft. We have the center of gravity down here. We have the fuel tanks, the center tank and the right and the left wing fuel tank over here. So it contains a lot of fuel sometimes. We have 30% right now, left and right wing, and 10% in the center. So you can see also we have over here the elevator. So we have also the vertical axis is the yawing axis. We can use the rudder for making left and right turns like this, for turning the aircraft around its yawing axis. Or in the ground we can use the nose wheel steering over here, the nose wheels for making left and right turns. They deflect 76 degrees below 45 knots airspeed, as you can see, the tiller over here. Or they deflect, you can use the rudder pedals, they're interconnected many times, or you can disconnect. So they deflect after 45 knots, the rudder is aerodynamically effective, and the nose wheel is decreasing to 7.5, 7.6 degrees until 70 knots takeoff speed. We have only the rudder aerodynamically effective, and we lose the tiller. So they're interconnected until some airspeed in takeoff, until maybe like 70 knots. We have control both. So the rudder is aerodynamically effective. You have the yawing axis like this, the rudder pedals. So we have also, this is the lateral axis from one wing tip to the other. It's the pitch axis. We control the elevator for climb descent, which in the Airbus side stick is the up or down, back or forth. It's for climb and descent. Also the yoke of the Boeing is making the same thing. So you climb or you descend the aircraft using the elevator tail like this, as you can see. So this is the pitch axis, the elevator, the tail of the aircraft, the horizontal tail. It moves up and down like this. So you climb or you descend. You have also the yawing axis, the rudder. And we have the last axis over here, from the nose to the tail of the aircraft, that transverses all the other axes, is the longitudinal axis. which is the roll axis. We can make turns left and right like this, bang rolls left and right. So this is the roll axis, which is in this Airbus's left and right side stick. It's the roll axis, up and down side stick. It's the elevator pitch axis. So you can see left and right turns, the roll axis, quite easy to remember. Easy also. We have here the control wheel instead of the side stick, which is doing the same thing in the Boeing aircraft. Like in the Airbus, you make the roll, right or left roll, and you have all controls, flight controls together. You have coordinated flight. For making right turns or left turns, you use both control wheel and rudder pedals. You will see later in flight. And the elevator, and we have also the elevator pit stream over here. You can see the small switch, so I'll talk to you about now. So the last thing before the aerodynamics, you can see we have the wings of the aircraft. Also we have the bottom surface of the wings is more flat, and also when we accelerate for takeoff like 140 knots, we have the flaps extended like this, and we have it's more flat than the top, and also the flaps extended. We have an angle of attack like this, so the airflow using the Bernoulli theory of fluid is moving much lower below the wings, so we have higher pressure below the wings, which pressurizes the wings up into the air with the weight of the aircraft. Also you can see the top surface of the wings is more curved, so there is a higher airflow, higher airspeed of airflow above the wings using the Bernoulli theory of fluids, which sucks the aircraft weight and wings up into the air. So this is the principles of the aerodynamics we need to know, the forces of flight, which is a combination. So now I'm gonna show you the horizontal trim stabilizer. So we have the horizontal tail for moving the side stick up and down. Instead of moving, you can use the side stick over here, control switch in the Boeing 787, so you can trim the horizontal tail up and down as you fly instead of moving the side stick all the time. So you can pitch up or pitch down the elevator, which gives an aerodynamic effect. You can see here elevator, the alternate pitch trim over here. I'm gonna show you the normal, so you can see nose pitch trim up or down. So this is elevator pitching up the nose of the aircraft as you fly. This way you pitch down. So you have the switch here, you have the cutoff switch for the horizontal trim. I will explain it now. You can see also we have the parking brakes over here, this handle. So we have this switch, which is the normal channel of the flight control computers. So you can see we can trim the horizontal elevator like this. This way you trim the elevator up, this way you trim the elevator down. So turning the elevator up, you pitch the nose up, and also you pitch the nose down when you trim the elevator down. So you can see elevator trim, left click down, right click up. So this way you pitch up the aircraft, very important as you fly. This way you pitch down, you give an effect, maybe you see better. Better view like this. Elevator trim, left click down, right click up. So this way you trim up the elevator, this way you trim down. We have also the autopilot disconnect switch over here and the head-up display. The clutter switch, we have the flap speed limits over here. You can see some other functions. So you trim the horizontal tail like this over here, trim up and trim down as you fly. And you use also the alternate pitch trim over here. As you can see, alternate pitch trim, pitch up or pitch down. Also we have, since this is a fly-by-wire aircraft, You can see we have the flight control computers over here, the primary flight control computers that control the deflection of the flight control surfaces in flight. So we have primary flight control computers in the auto position. So when we fly, we have the automatic trim of the aircraft over here. When we fly with the autopilot, flight director system panel in the auto throttle. So this is a fly-by-wire aircraft. It has the flight control computers. When we fly like this, we can fly either manually the horizontal trim stabilizer or automatic. We have the auto trim function from the autopilot flight director system panel, the auto throttle, and the flight management computer commands. And so we have if we have a failure over here of the hydraulic system, you can see the primary flight control computers. We have the normal channel is over here, the alternate is over here, and the direct. So we have the normal, the alternate, and the direct mode of the flight control computers and channels of the flight control computers. So we have a hydraulics failure over here. You can see the hydraulic system, the left and the right engine driving primary demand, and the electric C1, C2 that will affect over here the autopilot flight director system panel and auto throttle from controlling the horizontal stabilizer automatically, the auto trim system. You come down here, you open this red guarded switch. You see here cutoff. So this is for all Boeing 737, 747, 757, 767 and Boeing 777 and 787. You open from normal cutoff and you lose the automatic trim, and you have only the alternate and manual trim switch after that. So you keep having the alternate or the normal pitch trim like this, so you can trim the elevator into normal function, nose up or nose down, or over here as you can see. So you keep trimming manually over here, as you can see, elevator trim, pitch up or pitch down on the nose of the aircraft as you fly, very important. There is no trim wheel like in the 737 or in the Airbus aircraft. You have only the switch, and the switch will show you how many degrees you deflect the elevator trim, nose up or nose down. Over here it's 5.35 degrees. Maybe we need to decrease it a little bit, rudder trim also. So we keep trimming down a little bit, you will see you can trim it down a few degrees. So we have a few more things to see here. You can see we have the flaps and the slats, the speed brakes. Over here the flight management computer. So we have the flaps, slats over here. We track, extend, which are secondary flight controls. The thrust levers also. Extend fully. The speed brakes over here. So you can see how many degrees you extend or retract the flaps over here. You will see the flap surface is moving up, it's in transition now. You can see from the outside also the flaps are retracting right now. So we can re-extend them again to about 30%, 30 degrees or full. So we have also the speed brakes like this. You can see the speed brakes extend and retract. This is this switch over here. We have the fuel control, left and right engine fuel control. The auto throttle disconnect switch over here. This switch disconnects the auto throttle, the takeoff ground, the thrust reverser for the left and the right engine. So this is the thrust control. The fire extinguishers for the left and the right engine, pull out and switch, the transporter the radar trim over here. Also you can see the high frequency VHF, very high frequency satellite coming ground proximity with a radar transporter. So we have a couple more things to see before showing you all the flight controls fully. So we have also over here the flight controls, one more explanation. You can see we can climb, we can descend, we can make turns to the right, the left, horizontal trim stabilizer, the thrust levers over here. You can move the thrust levers also. You can see I have in the size here, command the thrust levers control, and the horizontal trim stabilizer. So we have full flight controls like this. Climb, descend, make turns right, left, and also I'm gonna show you one more view of the flight control system, and then I'm gonna show you the flight management computer, how to create a flight plan, complete flight path or flight plan or route for flying this aircraft. So I will show you now the rest of the flight control system and one more closer, more nice view. I hope you like it. So you can see I'm having the side stick, the Lszh Stream 3D, which is identical to the Airbus side stick. So hope you like also this view. We can climb and we can descend, we can make turns over here. To the left, to the right. So you climb, descend, you can see the side stick deflection is proportional to the yoke deflection. As you fly, also the control wheel, as you can see. Also we have the captain and the first officer over here move together in flight. They're interconnected. All flight controls for the Boeing aircrafts only, not the Airbus. You have the side stick priority. You can use either left or right side stick when flying, but the Boeing has interconnected flight controls unless you have a failure of the flight control system. Perhaps the hydraulics affect them. So hope you like I'm using the side stick. It's very easy. You can see how fast it deflects one side or the other. So I'm gonna show you a couple more things over here. Also the outside view, also the thrust levers. You can see we use the thrust levers a little bit more closer. Look over here. Move forward or aft. So we have full thrust control, very easy. Just like in the original aircraft. So a little bit more also the outside view. One more time, so we climb, we descend, we make turns to the right, to the left, all flight controls flying together. So this is all flight controls lesson for tonight. We go inside for the rest of the systems. You're gonna see. I'm gonna show you the flight management computer right now. How to use the flight management computer. How to create a flight plan. So we're gonna use the flight management computer now. How to create a flight plan. I will show you its functions. How to control it using the mousepad of the aircraft also. The flight management computer input, so we input all the data of this aircraft for this flight. The takeoff gross weight plus that includes the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and the right wing in the center tank. So I'm gonna show you. You can see another aircraft also coming for landing. So I'm gonna show you the flight management computer. So we have 30% in the left and the right wing fuel tank, 30% fuel, 10% in the center tank, and also the flight management computer is gonna calculate the loads from the fuel and the passenger and the cargo on board the aircraft. It will give us the mean aerodynamic chord position of the aircraft and the center of gravity in terms of the mean aerodynamic chord position, where the stall begins and the maximum aerodynamic lift also used as we fly. So as we fly, we burn fuel, so the center of gravity is being shifted in flight. So it's recalculated every second from the flight management computer automatically. We don't need to do nothing in flight for this. That affects also the autopilot flight direction system panel, the auto throttle, the FADEX commands, and other functions, the flight control computers. So we have also, and the auto trim, the horizontal stabilizer trimming. So we have all these functions. We're gonna use the takeoff runway, the runway 14 in Switzerland, Lszh airport in Switzerland, the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, and the temperature of the air. The flight management computer is gonna calculate the takeoff speeds, the V1, V-rotate, and V2. Also the runway conditions, if it decides right away, it's gonna give us the takeoff speeds. So we're gonna have a takeoff speed about 130, 140 knots. We're gonna use 15 degrees of flaps and 4.25 degrees of horizontal trim stabilizer for this mean aerodynamic chord of 23% and center of gravity. So we're gonna have a pitch attitude of 9 degrees for rotation, initial rotation in takeoff or less than that, and an airspeed about 140, 150 knots for takeoff. Then we're gonna have also in the flight management computer the seats. The seats are the cellular instrument departure waypoints and fixes that include horizontal and vertical navigations, fixes, and altitude and airspeed constraints for the initial climb and departure of the aircraft. You're gonna see how I'm gonna use them. We're gonna have them inserted in the flight management computer. We're gonna climb to the cruise level like 25, 26, 27, 28, 29, 30,000 feet above the sea level. We're gonna cross through some waypoints as we fly, make some turns. Then we're gonna start to descend the aircraft back to the airport. Let's say it's in Switzerland again. The airport elevation 76,000 feet above the sea level for the terminal approach and landing. So we're gonna align the stars with other terminal arrival waypoints and fixes that include horizontal and vertical navigation fixes and altitude and airspeed constraints for the terminal approach and landing of the aircraft, the long final and the short final approach, and you're gonna see how we're gonna do that. So we're gonna be aligned also with the Lszh localizer with the magnetic north pole heading of the runway 14 in Zurich International Airport, Lszh in Zurich. So we're gonna be aligned with the 136 degrees of magnetic north pole heading with the Lszh localizer frequency, the instrument landing system. So we're gonna be aligned with the localizer and the vertical glide slope that transmits the radio frequencies from the runway threshold antennas, and they are received from the onboard antennas of the aircraft and display the localizer and the glide slope, and also the Lszh localizer curve. We're going to be having 25 to 30 degrees of flaps extended for approach and landing, and airspeed 160, 170 knots. Also the landing gear extended and a pitch attitude of 9 degrees or less for approach and landing. So you're gonna see the complete flight, and also we're gonna have a complete flight path or route for this flight. So I'm gonna start with the flight management computer. You can see here we have so we have here to input all the data. I'm gonna use this mouse pad over here. You can see the mouse of the aircraft. So we use the touch screen to input the data here, to use the control. So I'm having my mouse pad also over here, as you can see. So I'm gonna use this to control the function of the aircraft data over here of the flight management computer. So you can see I'm using the mouse pad here. So we have, you can see the screen here. It makes a purple box whenever I select something like the index or something from the screen like legs hold. You're gonna see in a couple of minutes. So we have the identity over here, position, performance, takeoff, approach, annunciate status over here, navigation data, flight plans, load air traffic control, load plan, save plan, save plan. So we have the entity here. We have also the alphanumeric keyboard to insert things. We can set also the displays here with the mouse pad, as you can see. So I'm gonna use it to make a flight plan, create a flight plan, the flight planner of the aircraft. So I'm going in this view to show you how to use the flight planner, and we're going in takeoff for a couple of minutes. You can see again the mouse pad, the engines over here, a nicer view of the cockpit, center view. So we have here the identity, position, performance, as I show you. It's a Boeing 787-900 ZNX engines. Install the air rack cycle, the position. So we have a Lszh in Switzerland, Zurich International Airport. We're gonna use this for takeoff. The coordinates, we can align the inertial reference, position, performance here, gross zero fuel weight and fuel on board 322.7 and fuel 34.3. Gross takeoff for gross weight for takeoff 357,000 pounds. The cruising altitude, cost index, freezing fuel temperature, cruising, center of gravity, reserve fuel. Gonna set everything. So we have the route first, Lszh in Switzerland, Zurich International Airport. Copy paste over here, back. So we copy paste, clear the data. So we insert also the runway 14, departure and arrival over here. So we use departure. We can select runway 10, 14, 16, 28, 32. So we select runway 14, and we have the seats just arranged with departure waypoints and fixes in the left side. So we use U2 alpha. So we have departures and arrivals. Again, index, as you can see. So we use the arrivals. We can use VOM 162834. Over here ILS 14, ILS 16. Also we have ILS 28, ILS 34, GLS 14 localizer, 28 localizer 34. So we can select either runway. We're gonna select ILS 14. Transition waypoint is the Amity, and the stars is other terminal arrival waypoints and fixes. Negria 1 alpha over here. So we select the Negria. So we have the route displayed with blue color, is not yet active. We have it here to set the fuel on board again, and the gross weight and the weight and fuel on board. So we have 35,300. So we have gross weight with the passengers and the cargo and the fuel on board. So we have cost index 100%. Fuel freezing temperature over here -37 degrees. Reserve fuel 5%. Again, 28% is the center of gravity. Percent that's of the aerodynamic cord for flying. So we press the execute button. You will see the blue change to white and purple over here. So it's yet activated. Now it's active. So we have an active flight plan over here. From our first waypoint over here, climb. Over here also we have maybe a discontinuity, the Amity. We cancel, again execute one more time. So we have the first waypoint is heading 136 degrees, the heading of the runway, 2 nautical miles, 250 knots, 1900 altitude. Then 1 nautical mile, we have the heading of the runway for takeoff, 1 waypoint by another, 3 nautical miles, 56 is the Zui. We make a left turn, 052, 6 nautical miles, 250 knots, airspeed 6000 alpha. So this is the flight plan, active route. Negria, we make a turn 071, 26 nautical miles from Zurich, 250, 4000 alpha. So maybe we need to insert again the altitude. So we need to reset the altitude over here. Performance 35,300 over here. So we have the altitude now corrected. We're gonna have to cross through Mativ, 12 nautical miles, 246,000 alpha. Make a right turn here, Amity, 6 nautical miles. 140 knots, 6000 altitude, SUI 270 knots, 6 heading 9 nautical miles. From Amiki 140 knots, 7000 alpha, ZH Zurich 701, 6 nautical miles, 146,000 alpha. TRA 140 knots, 5000 alpha, CI 144,000 alpha, Osnem 144,000, runway 14, we make left turn here, 8 nautical miles from Osnem, 140 knots. So we use the flaps for approach and landing over here, center of gravity, and the takeoff speed V1 we rotate V2 for this center of gravity. So we have a complete flight plan over here, the legs are created. So we go back into the screen here. We have to use the APU. We're gonna start the engines, make an engine start demonstration. So you can see the electric panel over here. I'm gonna show you the panels, its functions. So you can see we have the flight plan now created over here. You can see the route over here, also the autopilot flight director system panel. We're gonna set heading 360 degrees for takeoff, 136 the runway heading, the altitude over here, the airspeed and the altitude. I'm gonna set later if we need, no problem. So we set like 35. So you can see auto throttle left, right over here, LNAV and VNAV. We have flight director on and off. You can disarm the flight director off. Autopilot disengage over here. So we have also the vertical speed we're gonna set. We can set a descent like this, or a climb like this. So we're gonna set over here in the overhead panel. We have the electrical left and right engine IDG, the great drag generator, 180 to 200 volts for 100 Hz frequency, the primary flight control computers in the auto position, the battery over here, as you can see, the air data computer, flight control surfaces over here, towing power FT door over here, passenger oxygen, window heat, rammer turbine, hydraulics. If we turn the off position, the engine driving, left and right engine driving, we see what they display. So we turn back to the on and to the auto then. Also we have the electric driving pumps over here. So we have the recorders, the cargo and APU fire, electronic engine control for the engine that controls the fatics, normal and alternate mode, and the auto start system, electronic engine control. Fuel jettison, we can dump some fuel in flight, lose weight and select the nozzles and how much fuel to remain. We have the fuel booster pumps, left and right wing, fuel and center, and also the crossfeed valve which are on. We can feed either engine with either pump or either tank and balance the fuel between the left and the right wing like this. So we have also the wing and engine radii over here on our auto position. We have the lighting system and the windshield wipers over here, and also very important, the pressurized air from the left and right engine from the APU. We need for cabin pressurization and oxygen, also air conditioning. So as we fly, either manually, fuel valves open and close, or automatic, we need to do nothing. It's all set by the computers, controllers. So this is the overhead panel before making an engine start demonstration. Also the system display in digital format before we make an engine start demonstration. So you can see here we have the hydraulics, APU is running, oxygen and liquid cooling. The electrical here, you can see the left and the right engine driving, 180 to 200 volts for 100 Hz frequency. The APU is running, and also produce electric current, main battery and APU battery volts and average. The load cell, also hydraulics over here where the hydraulic fluid goes with system used. Shut-off valves, left and right engine driving, primary and demand, 5000 psi its left and right and center system, how much quality we have, electric also, the fuel quantity, fuel tanks, left and right and center tank, left wing, right wing have 11,000, 11,000 and 11,000 total, 33,800. So we have the low and high pressure fuel valves open and feed both left and right engine from the center of the left and the right wing. The APU is fed from the left wing using this motor. The crossfeed valve is off, but we return it only can feed either engine with either pump or either tank. Also we have the fuel transfer for heating up the fuel in flight, because the fuel is gonna freeze from the firex automatically into the engine components. Also we transfer the lubricant and the oil into the engine components. You can see the minimum fuel temperature is gonna freeze below -37 degrees, and the fuel temperature are now -6. So we have a couple more things. The air pressurizer from the left and the right engine. Oxygen doors are closed, the cabin can be pressurized, the gear, the temperature of the brakes and the pressure of the tires. Flight controls, here you can see the deflection of all flight controls when we fly the tail, also the rudder. So this is one of the last things we need to see, the flight controls deflection over here, rudder pedals also. So we have the FS display, maintenance over here, systems, circuit breakers, here systems. So we go back to the checklist over here, normal checklist, what to do before start, after start, after takeoff, descent, approach, landing. So we have the navigation display over here again. So we turn off both engines and we go for takeoff after we start them. So both engines in the off position, as you can see, fuel control to the off. You see what happens, the display over here a fault is happening because we have the engines off. So we need to restart them very quickly, as you can see. So you can see the hydraulics closed also, the speed brakes. So we restart over here automatically. The auto start, both left and right engine driving. So we have the auto start now. We have pressurizer right now, and one is 18%, above 20%. We can let fuel flow. So now we have only pressurizer from the APU. So we let the fuel on right now, both left and right. So we have the auto start, 20%, 30%. So you see it's increasing. We have pressurizer and also fuel right now, 40%. So above 51 we see the message is going off, and we're gonna have running engines at 60%. Over here 61, we have both with green, so we can go for takeoff, flaps for takeoff over here. Speed brakes up, thrust levers, parking brakes off. So we take the clearance from the air traffic control and we go in for takeoff. So we use the tiller again for steering. The runway is open to us from the air traffic control, so we can proceed for takeoff, as you can see. So we advance the thrust levers, use the tiller to align, advance the thrust levers, full takeoff power over here, as you can see. So we have like we need to press the yoke down until 100 knots. So we have right now 80, use a little bit left rudder, 120 V1, we rotate slightly, rotate the aircraft back, repeats up a little bit. So we take off like this, as you can see, very easy rotation. So landing gear up, we have positive rate of climb, as you can see. So this is what we need to see over here after takeoff. All the data. We have the airspeed 200 knots over here. We are 1,900 feet above the ground, 2,000 feet above the ground, 2,300, 400 above the ground, but 4,000 feet above the sea. The airspeed is 185, 80 knots right now. The slow speed, the wind direction and speed here. The flight plan. So you can see the terrain with green, yellow, and red. You can see we are about 2,500, 3,000 feet above the ground. You can see the aircraft symbol over here, so you can see the ground below you. These waves over here, the green waves, is the terrain below you. Again, the stall speed, the engine's indication. We need to pitch down a little bit the aircraft, as you can see. So we're gonna start the turn now. You can see also the red, green, yellow over here, indications from further away. So we need to start the aircraft turn. You can see where we are right now. So we are after takeoff, the runway behind us, the airport. So we need to turn, make a turn here. Very easy. We can leave the hands off, no problem. For this aircraft, it's fully automatic. Even if we don't use the autopilot on, we have no problem for this. It keeps flying by itself. So it has the auto trim and the flight control computers also. So it keeps flying the heading you select, like in the Airbus. We have to level off a little bit. So this is the air data again. You can see the airspeed, the altitude here, the stall speed, the wind direction over here. We have 22 knots of wind, heading of the wind. Also the range, 80 nautical miles, or to 80 nautical miles right now, the ground speed. So we need also to see the flight line here. So you can see we follow a nice route over here. So we have a few more minutes to go. And to follow also the waypoints here, as you can see, the Zui. So we have a very beautiful view over here. Hope you like this view of the aircraft overflying the Switzerland, the Swiss Alps, the galaxy, galactic view, the lakes I'm gonna have in a couple of minutes. So gonna make a right turn now and align with the flight plan, and we have 12 more minutes to go back to the airport. So we cross 17,000 feet, maybe use a few more flaps to climb faster. To the cruising altitude we like. Hope you like this view. I'm gonna be having the France here, France, also Germany, my homeland, Bayern Munich over here, the lakes, and the Swiss Alps. We have a few more 1,000 feet to go, and we start the turn of the airport. You can see we have to fly through Zuri. It's 2.6 nautical miles away. The next waypoint, I'm gonna be overflying the Nigria now. We have to intercept Nigria. As you can see, it's 34 nautical miles away. You can see also the other side display over here with the bigger view. Also the head-up display over here. The engines, also the flight management computer as we fly. So we need to start the turn now for going back to the airport, as you can see. So we start the turn over here, and we're going to the airport. Very easy. So this is the turn here. Hope you like the turn over here. Overflying Germany, my homeland, Bayern Munich over here, the lake in Switzerland. Boeing 787, 21,380 feet, or about 7,000 meters above the sea level. We're cruising very close to the galaxy, the star sign. Hope you like the Boeing 787. So we keep turning a little bit more steep turn now. Increase the rate of turn over here. So we need to align, also use a little bit right rudder for this turn, rudder pedal to the right. So we are 33,000 feet, we need to leveling off, flaps a little bit up. Make a little bit more turn over here, align with the flight plan, these lines over here. So this is us over here, we're flying this beautiful view. So we have the chemtrails over here, the frozen vapors from the exhaust of the aircraft, from its tail. So we use a pitch attitude down now. Increase the thrust and pitch down the aircraft. Reach the stall speed limit again. We need to start also the descent to the airport. So here we are overflying this beautiful galactic view, as you can see. So we have the lakes here, we can level off. The Germany behind us, the France over here, very beautiful galactic view. The Switzerland. So we're gonna start the descent now over here. So we start descending over here, approach for landing in a couple of minutes, as you can see. Very beautiful view, the frozen vapors as we descend. We need to increase the rate of descent now. And also the airspeed, we have a few more minutes to go over here. As you can see, a few more minutes to go for this flight, like 5 more minutes. We need to land. So increase the rate of descent over here and approach for landing. So using idle thrust also. For this you can have also a nicer view of the cockpit again. So make a steeper approach and landing over here. And also faster, as you can see. A couple more minutes, I'm gonna be landing. So we need to be aligned with the runway heading over here. So here we have the runway inside, and we are approaching for the landing to make a little bit right turn over here. And we have 3 more minutes for approach and landing, as you can see. So we need to follow over here these waypoints, as you can see. So we use flaps full over here as we are descending. So we need to align with the runway heading over here. We have some side wind, some wind gust, a little bit so. the ILS localizer also. So we use a little bit more thrust when we need, align with the center line. Almost here. So we have the flare, touchdown, beautiful touchdown, parking brakes, thrust reverse, idle thrust and thrust reverse, as you can see over here. So we align again with the center line.